Now we are going to learn how to solve fractional equations. In both equations, we have fractions. So first thing we want to do is to get rid of all the fractions. In order to get rid of fractions, we're going to use something we learned before. It's called LCM. And so what we do is we're going to look at the denominators, the numbers on the bottom, and try to find the LCM of all the denominators. So in this case, we're solving for the least common multiple of 3, 8, and 6. And if you can see what the answer is, you can go ahead, write down the answer. The LCM should be equal to 24 in this case. But if you have trouble seeing it, you can either list, there are two solutions we talked about before. So you can either list all the multiples of each number and find a common one, the smallest common one, or you can use the factorial tree and bring down one number from each column. All right, so if you don't remember how to do that, and then go back to find the videos from previous chapter. Now, after we found the least common multiple of all the denominators, we do have a new name for this. We call it the least common denominator. The reason is it's the least common multiple of the denominators. So we call it LCD, which is 24. And what we can do is we take 24 and multiply each term by 24. So again, we got to remember one of the properties we talked about it before. When we have an equation, we got two sides. We need to make sure we always do the same thing, exact the same thing to both sides. So this time what I'm doing is I'm going to multiply the left-hand side by 24. So the left-hand side is this whole thing, two fractions. And I'm also going to multiply the right-hand side by 24. And since we're going to multiply fractions, it's better to write 24 also in the fractional form, put a 1 underneath. Similarly, we can do the same thing, 24 over 1. But I'm going to do that in this next step. Because on the left-hand side, there is a multiplication, because that's what I'm going to do. The first step when we solve fractional equations, we want to multiply. Well, first step we should be doing is find the LCD, which is the least common multiple. The second step, we multiply both sides by the LCD. So that's what I'm doing now. Multiply both sides by 24. And notice that in order to, in the inside parentheses, we have plus. So we have to, and in the parentheses, we cannot add these two. Well, there is a way we can add fractional, we call them rational expressions, but we haven't talked about these. You may have learned this in high school. And if you want to do the way you did it learning in high school, you can, what other instructors taught you to do. But personally, I prefer this way, which is also the way we're learning from the textbook. And even if you learned the other ways, I would recommend that at least you try this way in your homework. It's not like 100% required, but try to do different ways because this way might be actually is easier than just adding these two fractions. Okay, so let's multiply both sides by 24. And in order to multiply them, again, we don't want to combine them because it's hard to do. And I'm going to distribute 24 to both of them. So now I'm going to write 24 in the fractional form, 24 over 1 times the first one, which is x minus 2 over 3. The second one, 24 over 1. Distribute 24 to the second one, which is x plus 1 over 8. So that is the left-hand side. Usually, you may be able to skip the first step, putting, multiplying 24 on the left and the right. You can go ahead, jump to the step. If you understand, you're distributing it. So usually you can say multiply every term by, instead of both sides, you could multiply every term you see by the LCD. That also works. As you can see, after I distribute 24, it's like multiplying the first term by 24 over 1, the second term by 24 over 1. All right, on the right-hand side, it's just one single fraction. So we can go ahead and simplify this. And notice that we reviewed how to multiply fractions before. We can reduce 6 and 24 by dividing both of them by 6. And now we get 24 divided by 6 is 4. 6 divided by 6 is 1. Now we can multiply straight across. So I got 5 times 4 is 20. On the bottom is 20 over 1, but 20 over 1 is still equal to 20. On the left-hand side, we want you to do the same thing. We want you to reduce the numbers you see that you can reduce before you multiply them. So I don't really want you to multiply 24 and x minus 2. You want to reduce the numbers you see. So let's reduce them. Divide by 3, and divide by 3. That gives us 8 here. And similarly, 24 and 8 can be reduced to a 1 here, divide by 8, and to a 3 there. Now the next step, when we multiply the top, be very careful because the top, 8 times x minus 2, this x has to multiply both of them because x minus 2 are both on the top. And so it's better to put a parenthesis there to remind ourselves there is a distribution that we have to do. So we're going to multiply 8 and x, which gives us 8x. 8 times negative 2, negative 16. Notice on the bottom, since this 3 is reduced to 1, 1 times 1 is still 1. Anything divided by 1 is going to be, if I put it over 1 here, it's not going to change anything because it's still going to be anything divided by 1 will be the self. So you don't have to put that 1 there. Okay, similarly, on the second term, we do the same thing. We distribute 3 to both of them. So we get 3x plus 3. On the bottom, it's still going to be 1 that can be omitted, equals 20. So after we reduce all the fractions, all the numbers in the fractions, and we're going to get a equation with only whole numbers or integers in here. Okay, now we can solve this equation like we learned in the previous section. So let's combine like terms, 11x. So our goal is still the same, to get x by itself. Negative 16 plus 3 is negative 13. After we combine all the like terms on the left, now we're going to move the number terms, the constant terms, to the right by changing the sign, or it's equivalent to adding 13 to both sides. After we cancel, then we have 11x equals 33. And now dividing both sides by 11. That gives us a whole number as an answer. But in the homework, most of the answers are going to be, may not be for whole numbers. A lot of them are going to be a fraction, and you can leave your fraction as an answer. Okay, so that's the first example. The basic steps are, first step, finding the LCD, which is the LCM. Second step, multiply every term by the LCD, and then reduce the fractions and multiply. And you're going to end up with a whole number integral equation and solve from there. Now I'm going to follow the same steps to look at the second example. Now notice the small difference here is x minus 1. It's not really a fraction. You can still treat it as a fraction by putting a 1 underneath. Even if you don't put a 1 underneath, you need to realize this is still a term, or you can think of it's actually 2 terms. And you need to, whatever you multiply, you're going to have to multiply the LCD here also. So let's see. The first step, I'm going to find the LCD. In this case, either you put a 1 underneath or not, the LCD is going to be 9. Because 1 goes into any number. When you look for the LCM, 1 doesn't really change anything. So it's pretty much the same as the LCM of 3 and 9. So the LCD, in this case, is going to be 9. Again, if you don't remember how to do that, and go back to go over the videos from chapter 1. Okay, now we are going to multiply both sides by 9. Or you can say multiply every term by 9. But I'm going to slow down, and later if you want to skip the step, you can. So I'm going to multiply the whole left-hand side by 9 and the whole right-hand side by 9. And when I multiply the left-hand side, multiplication and addition in the parentheses, that means we got to distribute. So if you understand this and you want to skip this step, you can go ahead and write down 9 over 1, or 9 times the first fraction term, 2x minus 3 over 9, and plus 9 times x, which is 9x, and 9 times negative 1, which is negative 9. So you're going to distribute 9 to everything in the parentheses. But if you remember this, you don't have to put times 9 here, times 9 here. You can go ahead and just write down 9 over 1 times this, plus 9 over 1, or 9 times x, minus 9. Notice that I didn't put a 9 over 1 here because these are not fractions. There's not necessary to put 9 as a fraction. Okay, on the right-hand side, I do want to write 9 in the fractional form because we already have a fraction to multiply. Now let's reduce first. So remember, you always want to reduce this first before you multiply straight across. Previously, with numbers, you could do either way. If you want to multiply the top numbers, these two numbers, and then reduce later, you can. But in this case, don't do that. You're going to have to go back if you multiply them out. So don't try to multiply 9 and 2x and 9 and minus 3. To get 18x minus 24 and divide by 9, and then you won't be able to reduce. We haven't talked about factoring yet, so try not to do that. So remember, here you don't have an option. You have to reduce the numbers before you multiply. So now I'm going to reduce 9 and 9, and both of them will be reduced to 1. So when you distribute a 1, it's not going to change anything because 1 times 2x is 2x, 1 times negative 3 is negative 3. The bottom will be a 1 that can be omitted. And copy 9x minus 9. On the right-hand side, we can reduce 3 and 9 here to get a 3 because if you cannot see how we got the number, divide both of them by 3. So that will reduce the bottom numbers to 1. Again, they can be omitted. But on the top, we have to multiply this 3 with both x and 2. So I'm going to put parentheses here to remind myself. I got to distribute that 3 to both of them. So that gives me a 3 times x. So it's multiplication here. So it's 3 times x plus 3 times 2. That's 6. Now, no more fractions. So we can solve this by combining like terms first. So that gives us 11x. And these two like terms gives us negative 12. Now, there is still a variable term on the right-hand side. I'm going to move it to the left so I can combine them. So we subtract 3x from both sides. Or you can just say moving anything to the turn to the other side and just change the sign. So now we get 11x minus 3x, which is 8x, minus 12 equals 6. And the variable term is all combined, but we also have to move the constant term to the other side. So we can get 8x by itself. Okay, the final step is to get rid of that 8 there. So we divide both sides by 8. And this time we're going to get a fraction. And make sure your fraction is reduced. And notice that 2 goes into both of them. So we divide both of them by 2. That gives a 9 over 4 as the final answer. If you have time, always double check your answer by plugging the number into the original equation for the x. And the first one might be a little easier to check, but the second one with the fraction might be a little harder to check. But you can use your calculators to check when you check your answers.